Okay, so for this problem, you'll notice that we have a tank that's 100 gallons, but it only starts off with 20 gallons of sugar water that has a concentration of 4 pounds of sugar for every 2 gallons of water. Now, what's entering the tank is a sugar water solution that contains a half pound of sugar for every gallon of water, and that's entering at a rate of 6 gallons per minute. At the same time, a drain is open in the bottom of the tank that allows the water to leave at a rate of 2 gallons per minute. So as you can tell, if we have 6 gallons per minute going in and only 2 gallons per minute going out, our tank is filling up over time. So the idea is to figure out the sugar content when our tank is going to be full of sugar water solution. So this is very different from the other problem because we have a tank that's filling instead of being held constant. So to write our equation, we want to first start off with our dx dt. And again, our dx dt always has the form with our concentration going in, and you have to be very careful with this problem. It's the 0.5 pounds of sugar for each gallon that's actually going in. The previous information is for the stuff that's already in the tank at the beginning. So again, this is going to be 1/2 or 0.5 pounds in each gallon. Right now, the flow rate going in, that was given to us as 6 gallons per minute. And of course, we subtract, we have our concentration of the side of the tank, and then our flow rate going out. And they tell us the flow rate going out is 2 gallons per minute. Now our concentration inside the tank is always pounds per gallon. And just like in our previous problem, we're going to have x of t representing the pounds, this time of sugar in our tank. Our denominator is going to be the volume of the tank. And the volume of the tank begins at our 20 gallons. So that's going to be our first term. And then you'll notice that if we have solution going in at 6 gallons per minute, but it's leaving at a rate of 2 gallons per minute, then the net change in that is 4 gallons per minute. So that's going to be 4 gallons per minute times the number of minutes that's passing. In other words, if it's just going to be 0 time, it's going to be just no extra liquid. But after 1 minute, you pick up 4 gallons. After 2 minutes, you get 8 gallons, and so on. So that's going to be 4 times t. Again, it's just the 6 minus 2, the net change in the rate in versus the rate out. And of course, this is going to be measured in gallons for our denominator. All right, so that is our differential equation. The next thing to do is represent the initial condition. And they tell us that we have 20 gallons of sugar water, and then that's times 4 pounds per 2 gallons. So that's going to multiply to make just pounds, and that's going to be 40 pounds of sugar in tank at start. So we've got our differential equation and our initial condition. Now let's rewrite the differential equation over again so that it's simpler to solve. We have x prime is equal to 0.5 times 6, of course, is 3. And then it's minus, I can make it better, minus than that, minus our x of t, we'll call it x, divided by our 20 plus 4t. And then that's times the 2 that's over here. So our numerator is 2x over the 40 plus 2t. And we could actually divide the numerator and denominator by a 2 to get a simpler differential equation. So our equation is going to be x prime is equal to 3 minus x divided by 2t plus 10, with initial condition x of 0 is equal to 40. Now this equation, when you first look at it, might look a little confusing to classify, but sadly it is not separable. but it is linear because you will notice that the x's and the x prime are all to the first power, there's no functions, and so on. So the first step in solving this equation is to add that second term to both sides so that it's x prime plus the fraction 1 over 2t plus 10 times x is equal to 3. And then in the next video, we'll take this equation and we will solve it with an integrating factor and then answer our question.